Hey.
There we are.
I love that music.
There we go.
Yeah, me too.
That's the best part of the show right there.
That's it. Yeah. Regardless of what anybody says.
Okay. Agree. Agree.
All you have to do is click mute. How hard's that, right?
That's right. Yeah, just for a couple of seconds and it goes.
Right.
Yeah. It's like if you got a toothache, right?
Yeah.
Pick something for it.
Absolutely.
It'll go away.
It will.
Whiskey, it fixes everything.
When you go to your doctor, say, doctor, every time I do this, it hurts.
Right. Don't do that.
Don't do that.
Right.
Anyway,
Okay.
a little bit of astronomy philosophy.
Are you done?
Okay.
And that's our show for this evening. Thank you.
Exactly.
Hope you enjoyed it.
Okay. Good evening, everybody, and welcome to our Sunday night offering of Astronomy Outreach for March the 12th. The Sunday show. Hey. My name is Chris Kerr, and I'm your host this evening and creator of the social media channels known as Astronomy by the Bay. And I'm an amateur astronomer and a member of the Royal Astronomical Society of Canada, the New Brunswick chapter.
Yes.
First of all, I'd like to welcome back our co-host this evening for the Sunday Night Astronomy Show, Mr. Paul Owen from the Moonshot Observatory in beautiful Hampton, New Brunswick. Welcome, Paul.
Good evening.
And our other regular co-host here on the program, Mr. Mike Powell from the PFO Observatory here in beautiful St. John. Welcome, Mike.
Oh,
Hey, Pavo. Okay.
pretty far out.
Observatory.
Right.
This weather forecast show could be. We don't looking ahead to Tuesday at the moment. I know it's
Trust
not.
me, we'd be in tears if it was.
That's right.
Okay, on tonight's episode of the Sunday Night Astronomy Show, we live in a time when space exploration is becoming common, and we are learning so much from each new mission. More than 250 robotic spacecraft and 24 humans have ventured into space since we first began exploring beyond Earth's atmosphere in 1958. From the 6 spacecraft currently studying our sun to those that have made us wonder about the worlds outside our solar system, we're continually breaching the barrier of what is known about the universe we live in. Now, tonight, we thought it was time to check in on a few of those important missions. Mike and Paul and I have all chosen a few favorites to discuss. So we'll be talking about that very soon. Also tonight, Mike will bring back another Vinyl Bud for a fine binocular target of the week. Paul will be introducing another Rosanna's Fun Facts for us this evening to enjoy. I'll have a quick look at what to watch for in the coming week. There's not a whole lot happening, but it's still a few things to watch. And we'll have all of your wonderful photo submissions to share as well. Now, this is a family-friendly, interactive live broadcast. So for those of you joining us from my YouTube channel or Facebook page, we're happy to try and answer all of your astronomy questions here in real time as well. And of course, we'd like to welcome back all of those who have been joining us through the local Rogers TV network. Thank you for your support. Okay, guys, so let's get started then, I guess, with tonight's program and a look at some fascinating space missions happening now and that have happened in the past.
I think Mike was just trying to emulate the Hubble telescope when it first went up.
Yes, where it goes out of focus.
Exactly.
Thanks, Mike, for that talk.
Yeah, that was great. The
Done.
demonstration was.
Paul, you're up.
I got it. Yeah.
There it goes again. I got to stop moving, I guess. I don't know. Like I said, I shut the autofocus off and it still tries to autofocus. It must be Windows.
Yeah.
Because doors wouldn't work that way.
No.
Probably not. No.
Close the windows and keep out the critters.
What's all the German talk here tonight? Okay, whatever. Anyway, Mike, I guess that's up to you, sir.
Start. Okay. So yeah, we were chatting about what we'd talk about tonight, and in the order that we were going to talk. So we decided we would start at the sun and talk about the satellites and whatnot that's orbiting and researching the sun, and move ourselves out through the solar system slowly. So I got the sun. So I'm going to share my screen here. I think that should be coming up.
There it is.
Here, our sun. Who's watching?
Is that Colonel Sanders?
How'd you guess? All right. Well, we'll start with number 1. Hanode Solar B. Hanode, or Sunrise, is a project to study the sun led by the Japanese Aerospace Exploration Agency. in collaboration with NASA and the Particle Physics and Astronomy Research Council and the European Space Agency. So there's a whole bunch of them collected in on this one. Hinode, 3-year mission is to explore the magnetic fields of the sun and improve our our understanding of the mechanisms that power the solar atmosphere and drive solar eruptions. And there's a picture of what this Hinode looks like. So that's one satellite and its mission. I was only looking for SOHO because that's all I ever really look at for sunspots. And I was surprised to find out how many different missions are actually viewing our sun to find out what's going on. So that's the first one. The second one is the Stereo, and it's just what it sounds like. It's a solar terrestrial relations observatory. It's the third mission in NASA's Solar Terrestrial Probes program. Its 2-year mission will provide a unique, revolutionary view of the sun and the Sun-Earth system. The two nearly identical observatories, one ahead of the Earth in its orbit and the other trailing behind, will trace the flow of energy and matter from the sun to the Earth, as well as reveal the 3D structure of the coronal mass ejections and help us understand why they happen. So it's watching to see what's headed towards us. And there's what it looks like. It's 2 identical satellites. One's orbiting, like I said, ahead of the Earth. The other one's orbiting behind it. And they just continuously look at the sun. That's all they do. And then we got SDO, the Solar Dynamics Observatory. One of the following so great SOHO Solar Observatory launched on February 11th, 2010. The 3 instruments on SDO hope to study and gauge the dynamic processes that influence space weather phenomena. And again, that's another one that's looking to see if auroras and coronal mass ejections and all the particles that are headed towards us when the sun ejects something. And that's what it looks like. They've got a bunch of instruments on board. It's not very big. It's about the size of a school bus. Then we got SOHO, my fave spot, because that's where I go to see what the sunspots are doing for the day. This magnificent spacecraft observatory was launched in 1995. SOHO, developed jointly by NASA and ESA, contains 12 separate instruments designed to study the internal structure of the sun, its extensive outer atmosphere, and the origins of solar wind, that stream of highly ionized gas that blows continuously outwards through our solar system. So SOHO is the one I go to watch what's going on with sunspots for the day. And there's what it looks like. Just thought I'd show you a picture of each one. Now we got YOHO, or YOKO, the X-ray satellite. It's now lost, unfortunately, but orbited high above the Earth for 9 years, exploring the sun in X-ray. The dazzling red and yellow images it produced helped the world to see the sun as a variable and dynamic star that it is. And that's what it looked like. Then we got the infamous Parker Space Probe. The Parker Space Probe has 3 detailed science objectives: trace the flow of energy that heats and accelerates the solar corona and the solar wind, determine the structure and dynamics of the plasma and magnetic fields at the source of the solar wind, and explore the mechanisms that accelerate and transport energetic particles. And that's the one that actually flew into the sun, if I'm not mistaken, like just grazed it. And there's what it looks like with this big heat shield on the front. And that's what I was talking about. That's who's watching the sun. So here you go.
And you're watching it too, Mike.
I am.
And you're listening to it sometimes as well.
Sometimes, not as much as I used to, but still good fun.
There's a lot of probes keeping an eye on the sun, and the sun is pretty important for us to keep an eye on. Space weather forecasters rely on that information as well to provide them with information to provide back to companies who have satellites in orbit and could be at risk if we have a large solar flare, coronal mass ejection, and they may have
the electrical power grid around the world could be at risk if it's a big enough one. Yeah,
absolutely. Yeah,
put us back to the 1800s.
That's right. That's awesome. Okay. Something we can't cover all the missions. Again, there's over 200 alone. I think there's over 50 or so that just visited the moon. So all I did was I picked out, I didn't go like Mike did, because there are other missions to the moon. But I just picked out one that I thought was pretty interesting of all. Actually, 2. So let me see if we can bring that one up for you next. Okay. Here and here. Now I'll see if I can share screen. No, I'm gonna have to open it up first. Now I can share the screen, I think. So it's going to be screen number 1.
There we go.
Okay, so missions to the moon. I mean, there have been an awful lot of missions to the moon. I'm just going to go through, like I said, 1 or 2 here. We get my other screen open here too. This one. Here we go. Okay. Our moon has been the most visited body in the whole solar system. Missions to the moon have been conducted by the Soviet Union, United States, Japan, the European Space Agency, India, Luxembourg, Israel, Italy, and South Korea. Now, over 145 missions have been attempted since 1958, with 112 being successful. 22 missions ended up with spacecraft on the moon. So there are all missions that had spacecraft on the moon. The one I'm going to talk about, though, that I see that I still see information about is the Lunar Reconnaissance Orbiter. And I think this is one of the most fascinating ones, simply because it's so old now. It was only meant to last a year. Get into that discussion here. So the LRO, or Lunar Reconnaissance Orbiter, primary goal was to make a 3D map of the moon's surface from lunar polar orbit as part of a high-resolution mapping program to identify landing sites and potential resources, to investigate the radiation environment, and to prove new technologies in anticipation of future automated and human missions to the moon. The LRO has been hugely successful in its original mission objectives. It is still a fully functioning spacecraft, actually 14 years now after its original design timeline was complete. The LRO with LCROSS was launched atop a United Launch Alliance Atlas V rocket on June 18th, 2009. It arrived in orbit around the moon 5 days later. Now, NASA's Lunar Crater Observation and Sensing Satellite, or LCROSS, was launched with the Lunar Reconnaissance Orbiter to determine if water ice exists in a permanently shadowed crater at the moon's south pole. The LRO gathered information on day-night temperature maps, contributed data for a global geodetic grid, and conducted high-resolution imaging. Now, the spacecraft paid particular emphasis to the moon's polar regions, where scientists suspected there might be water in the permanently shadowed areas. Although it was not a primary part of the mission, NASA was aware that there was huge interest in capturing the locations of the Apollo landing sites in more detail. Now, the following mosaics are from images captured in 2019 from a height of about 60 kilometers above the moon's surface. Since the moon is basically in a vacuum, images from this height would still be very good quality. In the images, you can see the remnants of the astronauts' landers, their scientific experiments, their footprints, and the lunar rovers, just the way everything was left over 50 years ago. So there are the 6 landing sites that we've captured. I think we have a better image of it here. Apollo 11 for their Neil Armstrong's footprints out to the crater and back again, and their seismic experience that left behind. Apollo 12 with a Surveyor spacecraft, they landed over here and they tried to get close to this Surveyor spacecraft. That was part of their mission, to see how close they could get to it. Now 13, of course, didn't land, just orbited the moon and went back. Apollo 14, then we get into the rovers, when they parked the rovers, took the rovers to the moon, Apollo 15, 16, and 17. So lots of images there to dispute the naysayers, I guess. Just going to look at a quick video here that talks a little bit about LRO. Actually, the sites. It's going to show the sites. And if you take all of that data and compare it against the actual original footage, you'll see that it's exactly in the same spot. So So some of the LRO mission accomplishments developed an improved catalog of lunar craters larger than 20 kilometers in diameter, thus providing constraints on the ancient impactor population that affected the inner solar system. The first radar measurements of the lunar far side. It made the first global thermal mapping of a planetary body covering a full range of local times and seasons. More than 5 years of laser altimetric measurements yielding more than 8 billion topographic points, better than any other object in the solar system. So we know the moon very well. Improved the age dating of small landforms by using crater counts from the new high resolution images. So I forget what this one is now. Oh, this is a little bit about the mission itself. You can spend a lot of money on videos, can't they? They look pretty impressive.
Well, picture's worth 1,000 words.
It is. So that one kind of leads into the next part of the talk, which was a little bit on this guy, which is the Artemis mission, of course. The big one that's happening now, we've already sent one spacecraft out around the moon. Artemis 2, I believe, is supposed to launch later this year. And Artemis 3 is supposed to be the one that lands on the moon. But a little bit of that. I can't really get into this too much because I could do a whole presentation on this. Would take up the whole hour because there's so much happening with it. There's the actual spacecraft itself. Then there's the Lunar Gateway, which is a spacecraft or a satellite. Sorry, a space station that's going to be orbiting the moon. What they're going to be choosing for rocket or spacecraft to land from the Gateway down to the moon. The landers, the rovers, the whole bit. There's a whole pile of data on this, but I'm just going to go through a quick video here from NASA itself.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system with engines capable of the crew safety during launch. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it is the legendary Saturn V of the Apollo era in lunar space. entire rocket fully fueled just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there was all four RS-25 engines and the two solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent. The upper stage fires briefly into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems. Everything is ready for deep space travel. With a go from mission control, the crew reignites the exploration of upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also to arrive on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach. Positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time, and enabling ongoing science to be conducted even between new missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions cannot. But the real key in this approach is placing Gateway in perfect the maneuvers needed for Mars missions. And from the list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 steps. Descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and descending all the way back to the orbit of Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fired their engine once to bring up the halo orbit, and once again to slate the spacecraft around the moon. Back towards Earth. As they near the end of this journey, the service module is released, and the crew module is pointed to the heat shield first. As the Earth's atmosphere at 25,000 per hour, friction of air slows Orion considerably. To temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating craft to just 20 miles per hour for smart ground. Each successful mission, Artemis ushers in the next wave of to explore on the moon. And together, we are ready to go.
So that's what it's all about.
Yeah,
Busy, busy.
Busy.
lots going on.
That'd be cool to get back. See what.
Will be, yeah. I mean, that I brought that up because there's so many pieces and parts to it. Like, we still have to build the Gateway space station. The Artemis mission is just the first mission out so far. We still got to do number 2, get people on it, get it up around the moon. And then the third one is supposed to be the landing one. The lander hasn't even been built yet. I don't think it's even been designed yet. I think it's all to do with Starship. But I just look at the next generation of kids. Like we get to see it on TV, right? Watching it on a black and white television. They're going to get to see it live on YouTube or the live feed. So I think it's going to excite a whole new generation of astronomers and astrophysicists. And I think it's going to be a great thing for kids for space. I really do.
Funny, I grew up thinking the moon was black and white anyway, because of those videos, right?
That's right. Yeah.
You look at it through a telescope and it looks black and white, and then you start thinking, well, that's maybe all it is up there.
Yeah. But I think there's just so many pieces that are in. I've already picked a lot of the astronauts, the ones that are going to be going next. So anyway, that's my part. Paul, you're up.
All right. So I'm going to talk about a mission, which of course will include the device that was sent on this mission, and it's called Cassini. A lot of people have heard about it over the years. It got to spend a lot more time in space and in commission than it was designed to, which we talked earlier about that being almost the norm now. When they send things up, they tend to last a lot longer, and they tend to do a lot more than what they were intended to do. And Cassini was certainly no different than a lot of them. So what you're looking at right here is a NASA site, and this particular site is dedicated to Cassini and the whole mission. And anything you want to know about Cassini is on this site. And rather than me just taking a lot of information I would have transferred onto a PowerPoint and showing you, I might as well show you the site. And the reason for that is because this site is so full of information and can be used by a lot of different people in a lot of different ways, that I thought, well, I would just show you the site, just walk you through a little bit about, what Cassini is, and just show you some of the interesting things that you can do on here in many ways. In fact, Cassini, this site rather, has a lot of data that they're actually encouraging amateurs to go on and look at, because there's so much data that was picked up from Cassini and sent back to Earth that it would be impossible for anybody that NASA pays to people to go through it all. So there's that much data, but we'll cover that in a minute. So the basic thing about what Cassini is, it went out into its service in 2004. And its mission was actually just to be for 4 years. And it was actually it was actually in space for 20 years. It was actually at Saturn for 13 of those 20 years, which is unbelievable. But it learned an awful lot of what went on, or what goes on in Saturn and whatnot. So as far as the Cassini goes itself, it traveled over 4.9 billion miles. That's a lot of travel. And again, it was in space for 20 years. It had 294 orbits around Saturn. I mean, when you consider how large Saturn is, how long it takes to go around, that's a lot of circling. And it took almost 500,000 images. 500,000 images of all kinds of different things on there. And we'll get into that now. I'll show you some of the things that it actually took. So let's go. When you're looking at this site, by the way, it's got like an overview, the journey, what the missions were, a little bit about the spacecraft and all that. So if you want to learn, those kind of things about this, it's all there. I'm more interested in the gallery side of it, and that's not so much for looking at pictures, but for actually studying information. So if you go to the gallery side, it will show you some images, which we will look at. And actually, I'll look at them now. Let's look at a few of them. Let's go to images. And it actually gives you the images that Cassini actually took. And when you lay your mouse over top of any one of the images, it'll actually explain what it is that you're looking at. Now, there's one in particular I want to show you to start with, if I can find it here. Just bear with me a second. Here it is right here. And what this image is, it's called the Veil of Ice. Now, as you can see, when you open any one of these images, you can enlarge it and look at it, or you can actually download the original image itself in the form of a TIFF. There's also a spot on here if you want to actually download the raw data, you can do that too. But what's cool about this, and you may or may not be able to see it, but this is a shot of Saturn itself, which is the ball of a planet. And this is sort of the limb of Saturn that you're seeing up here. And then this whole system you're seeing going sideways, that's the ring system. Within that ring system, there's that little white dot that you see right there. Well, that little white dot is actually one of its moons. And the reason that that black space is there is because the moon is orbiting within the ring system, and it's keeping that black space there. So that's the reason why this particular portion of the ring is there, is because that moon is there. And so if you just go down and read below it, it'll tell you a little bit about what's going on with it. So this is called Saturn's rings, and this was made of countless icy particles from translucent veil in this view from NASA's Cassini spacecraft. So the moon that you are looking at is called Pan, and it's only 17 miles wide, and 17 miles across, and it orbits within the Encke gap in the A ring, and beyond what we can see. We can see the arc of the Saturn itself, and its cloud tops streaked with dark shadows, which are cast by the rings. Now, this image was taken in visible light with the Cassini spacecraft narrow angle camera, and this was back in 2016 when this image was taken, at a distance of roughly 750,000 miles away. And anyways, and then it just goes on to tell you a little bit about Cassini. So when you look at this really explains to me a lot of what goes on, maybe a little bit of how the particles are there, but a little bit more about one of the moons and one of its many, many, many moons that it has. And but I had no idea that the gap in the rings in some cases was caused by a moon that's actually in there. So that was just one thing that that struck me when I started looking at the site. Another one, of course, you can go on here and just pick anything, and it'll just kind of start telling you all about whatever you want to see. The cool thing about this is each and every one of these images was taken by Cassini. So these are not artist renditions of what it might look like. This is the real McCoy. This is really what goes on. Like for here, for example, the Cassini narrow angle camera image, one of those acquired in the survey conducted by the Cassini image science team of the Geyser Basin at the South Pole of Enceladus, which was taken as Cassini was looking across the moon's south pole. So check this out. This is off of one of the moons. It was looking directly across it, and this is what the Cassini was actually able to record. And of course, this data that they're getting back with these images is just absolutely invaluable, because it really, really teaches you an awful lot about what's going on out there. So that's just kind of just two photos in that gallery that I wanted to share with you. But I do want to show you this, the possibilities of what you can do with this data. So let's go back up to galleries, and let's go down to where it says amateur images. Now, these images you're going to see here are of people like you and me who decide, okay, I want to take this data and have some fun with it, or I want to take this data and study it, or whatever it is that you want to do, and they encourage this. So for example, let me just look at one that I thought was really cool. This one here. So this particular image you see here of Saturn from the top, a lot of us amateur astrophotographers, like it's been, I was telling Mike and Chris, I've been working on one project for 3 months because I can't get clear skies. Or if I do get a clear sky, I happen to be busy. Or if I'm not busy, then there's anyway, it's a pain in the potatoes to try to get some images sometime. So if you want to actually work away at astro stuff, that's true data by something, you can go here and do this. So this is Saturn filtered by Rick Ellis. So this fellow named Rick Ellis, just an amateur guy, he says, I was attempting to enhance the contrast and the detail of this classic overhead view of Saturn using various filters, and this is the result. So I'll just click on it and show it to you. So he took that data that Cassini actually took, the image, and he was able to go ahead and work on it and come up with an image, a result like this. This is stuff that came from Saturn. He's working on Saturn data. That's unbelievable. So that's one fellow who did that. There's one other one I want to show you, and it's right here. So this fellow here, March 21st, 26th, He says, I processed 2 images captured by the Cassini on March 21st to create an anguliph, basically a stereoscopic image that requires 3D glasses to see. So this is his image, and if you put 3D glasses on, you get this 3D image of this stuff that came from the Cassini right at Saturn. This is unbelievable, the stuff that you can do. And this just goes on. And like I was saying earlier, there's 500,000 images taken by Cassini. So if you want to study about things and learn things like we did earlier with that shot with the little tiny moon and the rings, there's a lot of amazing information about Saturn, because a lot of us, we look at Saturn with the telescope, and then someone comes to our scope and says, oh, look at this, aren't the rings pretty, yes, blah, blah. Go to this site if you really want to get into Saturn, because these are images from a spacecraft that was there for 13 years doing this work. And we have the benefit of either playing with the data, using it scientifically, or just learning a lot about it. So that's the one site I want to show you. It's called Solar System Exploration, Our Galactic Neighborhood, and it's a NASA site, and it's absolutely amazing. So that's what I want to show on this week's stuff.
Thanks, Paul. Yeah, I am familiar with that site. I've gone to that site many times looking for data for classroom talks that I do, and they list every planet and the sun, the moon, everything is in there, and all in depth too. Like,
yeah,
there's a lot of data in there.
Yeah, but what's cool about this is it's like you've got the download, so you can do what you want with that data, and they encourage it. To me, that's unbelievable, because you would think that they would spend all that money and then they wanted to do all that research themselves, but that's not what that was about at all. It's just This was a really special mission. It really was.
The public domain for NASA is wonderful. It gets it out there for everybody to enjoy, for sure. Okay, that's our bit of our talk. I mean, we couldn't cover much more than that in the time that we have tonight. So maybe we'll do another talk about some other fascinating space missions coming up as well. Mike, I guess we're on to you, sir. We're going to go with the Bino Bud next.
Bino Bud. What's this one? He should be popping up here.
There it is.
Alrighty. Binocular target of the week this week by Bino Bud is, and I hope you're getting ready for fishing season, the leaping minnow. You go, what is that? Well, the leaping minnow asterism is an informal grouping of stars that includes 14, 15, or 14, 16, 17, and 19 Auriga. If you include the water splash, and I'll show you what that is, there are over 30 or more stars of 9th magnitude and above, with the minnow itself being defined by half a dozen 5th and 6th magnitude stars, believe it or not. So how do I find the leaping minnow in the sky? On a clear night like we're going to have tonight, if you went outside at 10 o'clock, which isn't too late, oriented yourself to 255 degrees west-southwest, looked up, you'll see the bright star Capella, which is just out of the corner of this picture, but you'll make out the home plate or octagon, whatever you want to call it, of Auriga. And the leaping minnow is right down in here near the bottom 2 stars, between these two as you go across. Another look at it. You can make out this in the constellation. When you look up in the sky, there'll be M38, 36, 37. The leaping minnow is right down in here, and it's real easy to find. Trust me. What will you see? Well, there's so much in the area. It kind of looks like this. This is actually the minnow itself, right here, and this is the water that it's going to land in. Thus it's called the splash. It won't look like that in a pair of binoculars. What it will look like in 10 by 50 binoculars is this. And here you can see the minnow, and here you can see where the splash is coming down through here. And I believe this is M38 right at the end of the splash. So you got M36 down here in the corner. But the leaping minnow is jumping into this little water and it's making a splash. Compared to the full moon, oh golly, it's got to be what, 8 full moons across if you include the splash. So it's a big target, easy to find. And why did they, they could have called it the flying coffee cup. But they didn't. That's Binocular Target of the Week by Bino Bud.
Awesome. Thanks, Mike. A great target. Good one to get out there for. Auriga is still nice and high, so you still got lots of time to see that one.
Yeah.
Okay, I'm going to do a quick what's up talk then I guess next. What's up talk? Let me get my presentation open first of all.
This is where we need more music.
We do.
Yeah, yeah. Ba-da, ba-da.
Okay, that's enough.
And don't forget the.
Yeah, the piano thing.
Okay, a little bit about what's up this week. Just a quick what's up, really. Our active sun, if you've got a solar scope or a scope with a solar filter, excellent time now, of course, to enjoy our nearest star through the eyepiece. Our sun continues to be very active with 10 sunspot groupings yesterday. We're still ramping up to solar maximum expected in 2025, but it's getting to be very active. I think it's a lot more active cycle than they expected. Looking west after sunset all week, we still get this beautiful show of Jupiter and Venus. Although the conjunction of Jupiter and Venus has passed, you still have time to enjoy the evening planets as they blaze through the western sky shortly after sunset. Venus will continue to climb higher and become our evening star for some time as Jupiter continues to approach the horizon a bit earlier each night. So we still have about a week or two, I guess, anyway, before Jupiter drops out of sight. It'll be back. Tuesday, the moon is going to be near Antares. Now, if you're up before sunrise on Tuesday morning, you will witness our moon as it greets reddish Antares in Scorpius. Antares is the brightest star in Scorpius. It's about 700 times the size of our sun. And that's the heart of Scorpius. Also on Tuesday, we have moonrise, that should be Tuesday. Moonrise on Tuesday will be at 2:35 a.m. As noted, it will make a pretty sight next to reddish Antares. Now, later that evening at 11:08 p.m., the moon will reach its third quarter phase, but it won't be visible again until 3:47 a.m. on Wednesday, should be. Our third quarter moon spends its time hanging around out in our daytime sky, providing a nice reminder that it's not just an evening object. Over the next week, we've got the zodiacal light, best viewed from a dark sky site. The next week provides opportunities to try and capture the zodiacal light in the western evening sky. Now, the zodiacal light is the term given to the phenomenon, offering a strange cone of light caused by sunlight reflecting off of dust grains in the solar system. It is thought that this dust was the leftovers from the formation of the solar system. And could be. It might also be Mars dust. All week long, we've got Mars, Betelgeuse, and Aldebaran together. The southwest night sky continues to provide lots of celestial stuff to enjoy. Look to the southwest sky around 9 p.m. to check out the beautiful celestial triangle formed by reddish Mars, orange Betelgeuse, and red-orange Aldebaran. The three objects will offer this view all week long. So I'm going to be very close to this equilateral triangle most of the week. So lots to see in that part of the sky. Lisa's Look Up, Astronomy and More. You can go to Lisa's page. Lisa puts out this great calendar every month. She lists here again all the events that are coming up for the month, the dates of the events, the peak times, and what you would need to view it with, naked eye, binoculars, or a telescope. You can find Lisa at Lisa's Look Up, Astronomy and More, or at Moonbeams on Instagram, Twitter, Mastodon, and Facebook. And we also have our local calendar as well, the March-April calendar put together by Kurt Nason, who was our resident veteran astronomer. So here are the activities listed for this week coming up. Orion's Day. Anyway, then we start the Messier Marathon next week as well. So we can talk about that maybe next week as well. Anyway, you can go to sjaastronomy.ca, and that calendar is there for download if you'd like to get a copy of it. So that's about what's happening this week coming up. Okay. Let's close out that one. Okay. From there, we're going to go to Rosanna talk, I guess. Rosanna fun facts.
Just give me 1 sec here. I get that all peppered. It's already there. It was earlier, but it doesn't seem to be now. So we'll just do it again. Let's see here. My computer's being a little slow today, so somewhat like myself.
On all these happy people with a time change going on today.
Yeah.
Hey, it gets darker sooner. I like it.
Yeah.
It's darker later.
All right.
No, we had put it an hour faster. I lost an hour's sleep.
Yep. So it gets darker later.
Now it would be 7 o'clock. It's 8 o'clock.
Hmm.
I don't know. To me, it gets darker faster.
That over there. Okay, let me see if I can share screen. Maybe
The
perhaps.
sunlight's up longer. How's that?
Works.
But if you're up in the morning sky, you get lots of. You get
There you go. Yeah, that's
There you go.
hours.
There you go. Yeah, just switch over to being
One
morning
end to
person.
the other.
All right, so here is this week's.
Rosanna's Fun Fact.
Welcome back, Rosanna. And again, she has an extremely timely fun fact as usual. I don't know where she gets them, but she gets them, and they're always just exactly where they should be in the time frame that she gives them to us. So let's get into it. So she says, Rosanna says, hi, Paul. The Irish world is gearing up for St. Patrick's Day, Friday the 17th, where anyone who is Irish and anyone who wishes they were may be celebrating the green beer beverages accompanied by Colcannon and Caudle on the menu. But Irish folk have even more to celebrate with the addition of the first international dark sky place accredited in Northern Ireland. OM Dark Sky Park and Observatory, formerly known as Dava Forest, is a 1,500-hectare protected site in the foothills of the Sperrin Mountains outside of Cookstown, County Tyrone. Now let me just give you a picture here. Make it bigger so you can see. Oh, isn't that a sight?
Mm.
Set among the untouchable rural landscape of rolling hills and sweeping forests, its centerpiece is the Big Moor Stone Circles, a complex of early Bronze Age megalithic features, stone circles, and cairns. And look at that. Can you imagine? There's some beautiful sundogs there in the background. I don't know if you noticed that or not.
Nice.
It's fantastic. 2020 saw the opening of the Dark Sky Observatory and Visitor Center at the Forest, offering visitors a unique opportunity to experience some of the darkest night skies in Northern Ireland. However, the pandemic prevented many people from enjoying the observatory until more recently. The OM Observatory is the third dark place in Ireland and is home to a 14-inch LX600 Meade telescope. The Meade comes with a Starlock, a full-time automatic integrated guider, which assists with ultra-precise polar alignment, finds and centers targets, and then automatically locks onto a field star as a faint, one second, you're going to press the button. There we go. As a faint 11th magnitude down to 1 arc second guiding. For those who don't know what that is, don't worry about it. As it has fast advanced coma-free ACF technology, an internal Crayford-style primary mirror focusing system with a dual-speed 7:1 ratio. The OM Observatory also has a small Coronado ST400 40 to 400 PST solar telescope. These scopes are only operated by qualified staff, but there are regular exhibits, stargazing events, and sky tours. This is very cool. In 2016, after a lengthy period of night sky surveying and quality monitoring by students of Galway Mayo Institute of Technology, the Mayo Dark Sky Park was officially accredited with the rare gold tier status from the International Dark Sky Association. This is the highest designation awarded, meaning that the sites like the Aurora, the Milky Way, and faint meteors are visible. There are only 19 gold tier dark places designated in the world. It extends over roughly 60 square miles of wild Neptune National Park, stretching from the Neptune mountain range across Blanket Bog, or peatland, to the Atlantic coast. Because of the area's low population and rugged lands unsuitable for farming, its skies are some of the world's darkest. So that is unbelievable. Look at that.
Nice.
That's just amazing. So, and at last, but actually first, the Kerry Dark Sky Preserve below and I'm going to show you an image of it here in a second, was designated in 2014. The reserve runs along part of the Wild Atlantic Way and the Ring of Kerry, stretching from Kells Bay on the north side of the Ivory Peninsula to Cara Daniel on the south. Between the mountains and the Atlantic coast, some of the best places to observe the dark skies and surrounding views are at the 1,000-foot Kumanspig Pass on the Skellig Ring Walk near Port McGee. Now, excuse me if I'm struggling with these names because I've never been there, so these are all new to me. Or at the old watchtower at Bray Head on Valentia Island, which looks out to both the Skellig and the Blasket Islands. Can you imagine being there? Look how dark that is. Obviously, there's something lighting up that water. Probably a moon, I'm guessing, unless it was just enhanced, but either way, beautiful. The night sky has always been important to the people of Ireland, and many monuments built in this area during the Neolithic times lined up with the stars and the celestial bodies. A stone circle from the Bronze Age sits in Bonan Heritage Park near Kenmare, just outside the reserve, composed of 13 large stones, thought to be the center of an ancient astronomical calendar. And let me just make that so you can have a look at that. A calendar which tracks the solar and lunar cycles as well as moon rises. At sunset and sunrise on the summer solstice on June 21st, the sun directly aligns with the stones in the circle. Ancient inscriptions found on stones in the area, written using the old Ogmun alphabet, are also thought to be records of celestial calculations. Pretty cool. Although these dark sky park accreditations are relatively recent, the Irish folks have been looking up and stargazing for thousands of years, just like humans all over the world. The number thrice 9 is commonplace in Irish mythology, and Irish astronomers sometimes use this as an mnemonic for the sidereal month, where the moon journeys exactly back to its place among the stars in 27.3 days. Now, let me just flip another one here because this next picture is pretty cool. My mom was Irish, and for her 71st birthday, my younger brother and I took her to Ireland to track down some of her ancestors. This was in 2011. We didn't visit any dark sky preserves, but the night skies were sparkling well whenever they weren't cloudy. It felt like a lot of It felt like a lot St. John, and surely astronomers there get just as frustrated with the maritime weather. We talked about that earlier. Funnily enough, when we were in Cork, we stopped at a library to pursue an exhibition on Irish immigration to St. John, and especially the Partridge Island experience. The exhibition had been flown over from the St. John Museum. Cool. So since 3 is my favorite number, and I've only been to Ireland twice, it's time to start planning a third excursion, one that will include all 3 dark sky preserves and hopefully include the annual summer solstice event. I'll make sure not to have thrice 9 Guinnesses or Coronas though, lest I tumble lest I tumble over some stone circles. I've successfully mapped out the chromosphere and its photosphere. Can you identify the corona today? And there you go. It's all in Irish, and I can't say it. But happy St. Patrick's Day from Rosanna. That's
Awesome.
fantastic. And that's this week's.
Rosanna's Fun Fact.
Hey!
So top of the morning to you, bye.
That's awesome.
Fantastic. Thank you so much, Rosanna. And again, it's always so timely, right?
Oh, absolutely. Yeah.
Yeah.
How they laid out, how they laid out those stones. What's that?
Stuff from St. John over there to that museum. That's just amazing.
Yeah.
Right?
To picture those circles, how they laid out those circles.
Rosanna. Anyway, sorry.
Awesome. Thank you very much.
We could have circles like that on Partridge Island, but we'd never know because we can't go over and see it.
Yeah, that's right. That's right.
True. True enough.
There you go. Thank you, Rosanna. That was
Thank
awesome.
you, Rosanna. Yes. Yeah, I mean, to lay out those circles and get them aligned with, with the particular day and stuff, they only have 1 day a year to try that, so they had to get it right. Next year, okay, no, we had to move it over 6 inches. Okay.
Well, that's the advantage of being king, right? You go, don't move.
Right.
Poor guy gonna stand there until he gets it right.
Well,
But so many cultures around the world use that, the summer solstice and the equinoxes to help tell their time.
What's the date today? Today's
13,
13th.
13.
yeah. Is it really the 12th?
No, 12.
12 today. Yes, sir.
So we're what, 9 days away?
Yeah, from summer, from the equinox. Yes.
Yes. Yay.
Hey. Okay, let's take a look at a few photos then. Bring some up here. And we're going to go over here. Okay, let's get started here. I'm going to share my screen. I'm going to share this one. I'm starting to get the hang of this after 170 shows.
Catch on. I'll catch on.
170 episodes. This is it tonight.
Wow.
Wow. Okay, this one's from Dwayne Schwam. He says, "Hi, Chris. I was able to capture a photo of the sun pillar this evening, although from the time I first saw it until retrieving my phone for a picture was less than a minute, it was already less vibrant. Still enjoyed it for what it is. Sun pillars are awful nice to be able to enjoy for sure." There's a second shot of it. Thanks, Dwayne. And Michael Powers just sent us a picture that he was out snowshoeing and got a nice
Nice.
sun
Oh,
glow.
yeah. Look at that.
Yeah.
Nice.
Nice to see those. Yvonne Rudiger sent this one here. She had caught a part of the moon halo a few days ago while taking pictures of Sirius and Orion. You did so.
Nice.
That's nice.
Yeah, nicely done. Thanks, Yvonne. And Kim Houlihan caught this nice one over the city.
Oh, yeah.
Nice.
Looks like a plane flew right through the center right there.
Is that, it must be west side, is it Martello?
I think that's Fort Howe, I think.
Fort Howe, by the look of it.
Yeah. Yeah, because there's Harbor Station, so she must have been at Fort Howe, that area.
Oh, maybe. Okay, I see. Yeah.
And there's it looks like a plane flew right through the shot, but
Yeah.
anyway. Good stuff.
Beautiful.
Got this one from Matthew Dupre. Matthew says, "I just finished processing M81 and M82. It's a 36-minute total exposure and consists of 36 1-minute exposures stacked and then processed in Photoshop. I used a Canon T7i and a Celestron 9¼ with Hyperstar. Good job, Matthew.
Nice. Looks great.
Nice done."
Yes. Hold on.
Winston Koch sent this one. I took this tonight, he said, with my new phone, the Samsung S22 Ultra. Pretty good for a phone, eh? They're getting so good.
Oh, for a phone, yeah.
Unbelievable, what you can do now.
Unbelievable. You're right. David Hoskins, Leo Triplet. So this is the small group of galaxies comprised of Messier 65 top left, Messier 66 top right, and NGC 3628 at the bottom. My Red Cat 51 was not the best choice for these targets in spite of nearly 4 hours of integration time. Halifax light pollution enhanced by reflections from the snow cover didn't help either. That's true. So that's still a great shot.
Oh,
Yep.
either way,
Love
yeah.
love to see galaxies like that, like 3 in a shot, 3 or more. We're coming into that season.
Mm-hmm.
Here it comes. Chris Benoit at Eskimo Nebula.
Oh, yes, sir. Dead center. Beautiful.
Third center, yeah.
Yeah.
Good stuff, Chris. And the Tarantula Nebula, I believe this one. Yeah.
It is.
Good on.
Crab Nebula, sorry, Crab Nebula in Taurus. Yep.
Yeah.
Lights and darks, 30 seconds bias, SWSA Nikon D3200 and a Celestron refractor.
Yeah.
Good stuff.
M1.
Yeah. Kathy Adams. She said, "I saw this guy as a shadow just after midnight tonight. Grabbed my 7i and Samyang 135mm f2 and my tripod, a DxO Photolab 6 in Photoshop. Great barred owl nebula right in the tree off my porch. He sat still for the whole 13-second exposure."
Look at that. That's amazing. I'd love to get that kind of a bird.
Nice, yeah.
That's really, really
Nice and
nice.
clear.
Yeah. I've never got an owl yet. I would love to. That's fantastic.
Yeah, great job.
Well done.
And this one of Orion Nebula,
There you go.
Yes, sir.
still nice and pretty in the sky, even now. And we've got a gibbous moon here, I believe, too. There's a gibbous moon on the 9th.
There you go.
Nice.
Yeah, very nice. Thanks, Kathy. Robert Gadet, nice Jupiter Venus pairing there.
Beautiful sky.
Yeah, nice seeing.
And the same there as well.
Very nice.
And he's getting some pretty awesome sun shots.
He is, yeah.
That's just, it's unbelievable. Yeah, really impressed by this stuff.
Having fun with his new scope.
He sure is.
He's doing well.
Yeah, he is.
Well, these little white dots, I'm not sure what they are, but pretty neat.
They would be black.
Okay, just reversed. Okay, yeah. Nicely done, Robert. And Mr. PFO Observatory.
Oh, that was this morning.
Yeah.
There's
So lots of
happening.
groupings, like, lots of
Getting busy.
stuff. Was that?
It's getting busy.
Yeah,
It is getting very busy. Yeah, you're right.
it's really, really cool to see so much stuff going on.
Yeah.
Yes.
So nice to be
Nice
just
job, Mike.
more than one sunspot for sure. This one is from Corinne McDonald, the Jupiter Venus conjunction.
Oh, nice.
Yeah, nicely done.
Over the falls. Beautiful.
Yeah. And then she
Yeah,
sent me
Rob,
this
photo.
video, which I'm going to play
There we
here.
go.
She had this one of the moon. And,
Oh,
she had captured a couple of photos of the moon, and then she sent them in, and she said, "Well, maybe I'll take back the photos and I'll just stick on this video instead." So she sent this one in.
Wow.
Nice to see the cloud cover moving in over front.
That's. I just always love watching clouds go over the moon. Eh?
Yeah.
Moon.
Nice job.
Yeah,
Very well done.
great video.
I think you're almost done. There were 10 seconds left.
Oh, let's enjoy it.
There.
Oh, sweet.
Very nice.
Nicely done,
Nice
Corinne.
detail on the edge. Wow.
Yeah, very well done. So we love getting your photos. As you can see, we love sharing them as well. So you can send them into astronomybythebay@gmail.com, please. And we'll be happy to show them on our next broadcast. So that's that. And we stop sharing here.
There you go.
And just going to close this out.
Oh, one more quick thing before
Sure.
an opportunity. Paul, thank you for sending me those star party dates. Anybody who's wondering about the New Brunswick star parties this year, they have been posted on the St. John Astronomy Club website. So
Awesome.
just go in there, scroll down the page, find star parties, and it'll take you to the dates, and they're all there. So
Great. Thanks, Mike.
Great.
Okay, before we close out tonight, 1 second here, got one more thing here to do. Can I do that there? Yeah, okay, anyway. You want to mention or talk maybe for next week? I think Kurt Mason's going to be back with us next week to do another constellation talk.
Good.
Constellation talk of the month. So we'll have some more interesting information on his constellation of the month. I look forward to that discussion. So in closing then tonight, thank you for all of your support. Our special thanks as well to Rosanna, of course, for continued contributions to the program. Rosanna, thank you very much. Also, special thanks goes out to Trudy Allman and all of you who continually share our program. She does a lot of shares for us.
Oh,
We
yeah.
also hope that all of you who enjoyed or joined us from the Rogers Network enjoyed the program tonight. If you'd like more information about the wonders of the night sky, you can contact me at astronomybythebay.ca. Now, remember too, we do love getting your photos, so send them into astronomybythebay@gmail.com, and we'll be happy to include them on our next broadcast. And please let your friends and family know that we'll be back here next Sunday night at 8 p.m. on YouTube and Facebook to entertain you on astronomy and the wonders of the night sky. So for now then, from Mike and Paul and myself, we wish you a safe and happy week, everybody. Lots of clear skies. As we like to say, guys, open your eyes to view the skies and keep your scopes.
Point it up.
Good night, everyone. everyone.